Hello and welcome everyone. In this video, we are going to define rational equations and we will see how to solve rational equations, the steps, and then we will see some examples on it. What is rational equation? As you see the definition here, it says it is an equation which can be reduced and written in the form p of x over q of x equal to 0 form. Necessarily, the denominator q of x has to be different from 0. So how to solve rational equation? Let us see the steps. To solve rational equation, we can follow the following steps. The first step, factorize the denominators, both sides. The denominators has to be factorized and the LCM will be determined, the LCM of the denominators. The second step, restrict the domain or take out those 0 points of the denominators. The LCM 0 points will be undefined point, obviously. The third step, multiply both sides by the LCM and then simplify. After that, what comes? A linear equation will happen and then solve that linear equation. Finally, you need to cross-check your final answer with the domain. Those restricted number in number 2, step 2, those numbers will be excluded if you find those numbers as a solution at the end. Let us see by example. The first example here, as you see, it says 2 over x plus 1 is equal to 3 over x minus 2. As you see, the denominators, x plus 1 and x minus 2, both of them are linear. We cannot factorize further. What is the LCM? The LCM of the denominators will be just the product of the two because they don't have any common. X plus 1 and x minus 2 will be their LCM. So what is the 0 point of this LCM? What makes it 0? X is equal to -1. And what makes it 0? X is equal to 2. So the domain will be, the domain of this rational expression will be real number without these two numbers. Therefore, according to the step, we need to multiply both sides by this LCM. That means 2 over x plus 1 will be multiplied by x plus 1 and x minus 2 is equal to the other side also. 3 over x minus 2 also will be multiplied by x plus 1 and x minus 2 because this is LCM. At this point, we can cancel what is common, what you see diagonally. X plus 1 will be cancelled by x plus 1, then what remains? 2 in bracket x minus 2 is equal to, here x minus 2 cancelled with x minus 2, then 3 in bracket x plus 1 remain. Then we need to calculate this one. So 2x minus 4 is equal to 3x plus 3. Then reshuffle. The 3x will come here. It's going to be subtracted. Negative x remains is equal to -4 will go the other side and will be added with 3, which is going to be 7. Then what we have now at the end, we can multiply both sides by negative, so x is equal to -7. Now check this -7. Is it found on the number that we already restricted here? The domain we said a real number without -1 and 1. We need to check -1 and 2. Sorry. We need to check the final answer that we have. Is it the number? I mean, is this number found on the restricted part? No. -7 is not found on the restricted or on the excluded numbers, so that our solution set will be -7. This one is easier because we didn't factorize anything in the denominators. Simply already both of them are linear. Let us see some other examples. The second example here, it says x over x plus 4 minus x over x minus 4 is equal to x squared plus 16 over x squared minus 16. The only denominator which can be factorized is x squared minus 16 because both of here x plus 4 and x minus 4 are linear. But x squared minus 16, we can write it as x minus 4 and x plus 4 because this is the difference of squares, because 16 means 4 square, And then what is the LCM of x plus 4, x minus 4 and the product? It is the LCM will be x minus 4 and x plus 4. How comes? X minus 4, it exists in the first, no, it doesn't exist in the first denominator, but in the second and in the third it's found. So a factor which is found in either of the three or in either of any denominator will be taken. For example, x minus 4, if it is found only in one of the denominators, it will be taken in case of LCM. If it exists in all, you are going to observe which one is the highest degree of x minus 4. For example, x minus 4 the whole square found in one of the two like denominator, in any of the denominators, that's going to be taken, the highest exponent. That is LCM rule says. Remember LCM rule and try to divide that part. So the LCM will be x minus 4 and x plus 4. That means the domain of this rational expression will be the set of real number without 4 and negative 4. How 4 comes? What makes this expression 0, the first linear, and the second linear will be 0 at negative 4. Therefore, we'll multiply each of them by x minus 4 and x plus 4. Remember now, when you multiply x minus 4 and x plus 4, this is the LCM. Let's try to factorize it. The LCM will be this one. So when you multiply the first rational expression here, x over x plus 4 by x minus 4 and x plus 4, what happened? This x plus 4 will be cancelled, x plus 4, what remain up at x times x minus 4 remain. Minus, or continue the next one. Let us rub the green part. And let's use another color now. We are going to multiply this LCM by the second rational expression. Then x minus 4, as you see the denominator, it will cancel the x minus 4 here. And then what left? 4 in bracket, x plus 4 remains. The other side, the whole will cancel, because x square minus 16 means, we said already, x minus 4 and x plus 4. So when you multiply, the whole thing will cancel everything, and then what remains to the other side? X square plus 16 will remain. Then let us finish it. Multiply x square minus 4x, again minus 4x minus 16 is equal to x square plus 16 will remain. Now, as you see, there is x square both sides. You can cancel it. Then what left? Negative 4x and negative 4x is going to be negative 8x is equal to, shift this negative 16 to the other side, it will be added and it will be 32. Then divide by negative 8 both sides, so x value will be negative 4. But unfortunately, this negative 4 is found on the excluded part. You can see it here. So this negative 4 cannot be answered. So our solution set will be empty set, because negative 4 is the 0 point of the denominator. It cannot be an answer of our solution, our equation. So the answer is going to be empty set. Let us see more example. The next rational expression, what you see here, 3a minus 5 the whole over a square plus 4a plus 3 plus 2a plus 2 over a plus 3 is equal to a minus 1 over a plus 1, it says. So as you see here again, the two denominators, x plus 3 and a plus 3 and a plus 1 cannot be factorized. Both of them are linear. So we need to focus on the quadratic here. This quadratic is a square plus 4a plus 3. We have to factorize this if possible. How to factorize? Think of two number product, the constant term 3, because the coefficient of a square is 1, and sum the middle term, which is 4. Let us think of two number. When you multiply 3 and when you add them 4, obviously those numbers are 1 times 3. 1 multiplied 3 will give you 3, and 1 plus 3 will be 4. That means I can write this, both of them are positive, so I can write it as a plus 1 and a plus 3. So the first quadratic will be factorized and written in this form. Okay, let's write it under it. This is going to be a plus 1 and a plus 2. A plus 3. Now, what is the LCM? The LCM of the denominator would be, a plus 1 found in the first denominator, in the second not, in the third it's found, so it will be taken a plus 1 the same degree. If there is a plus 1 which is with highest degree, like a plus 1 square or a plus 1 cube, that's going to be taken because LCM rule. And again, a plus 3 is found in the first denominator, in the second also, but not in the third, it will be taken. There is no another common, and there is no even uncommon one. Everything is taken. Now, what is the domain? the domain of this rational expression or rational equation will be the set of real number, which make the first one will be 0 at -1, the first linear here, and the second one is going to be -3. These are the domain. Next step, let us multiply both sides by the restrict or the LCM. LCM is already here, it is. This is LCM. So when you multiply, the first one, it will cut all. Everything will be cut out, and what left? 3a minus 5 remain, plus the second one, x plus 3 and x plus 3 will cut out. So what left? 2a plus 2 times a plus 1 remain is equal to the other side. A plus 1 cut out and a minus 1 times a plus 3 remain. Therefore, let us finish it. 3a minus 5 plus, we have to multiply here. 2a times a, it's going to be 2a squared. And 2a times 1 is 2a, and 2 times a again 2a, which is going to be 4a. You can multiply and check, plus 2. This product is going to be this one, is equal to the other side also the same. A squared and minus a and 3a will be plus 2a. You can check it, minus 3 remain. Therefore, let's collect 2a squared here and a squared here. It will come, and then a squared remain. And 3a and 4a will be 7a. 7a, and these 2a will come and subtract. It's going to be plus 5a. Finally, the constant, -5 plus, let's go to the constant, -5 plus 2 will be -3, and this -3 will come and added, it's going to be 0, so is equal to 0 remain. Then let's go to the next page, a squared plus 5a. We said a squared plus 5a is equal to 0. At this point, let's take out common for these two. That is a. So what left in bracket? A plus 5 remains is equal to 0. Then the product of the two 0 means a is equal to 0 or a plus 5 is equal to 0. Then this is one answer. The other answer, we have to shift the other side. A is equal to -5. So we have got two answers, a equal to 0 and a equal to -5. But we have to check, we have to get back and check the domain. Those numbers, are they under the restricted part? I mean, if this number are excluded from the domain, let us check. In case of domain, we exclude two numbers, -1 and -3. We do not exclude 0 and -5. So these numbers work, and our solution set is going to be, the solution set will be 0 and -5. So these are some examples how to solve rational equation. Remember what is rational equation, and remember the steps how to solve rational equation. And these three examples how solve it, you can check yourself. But as an activity, I will give you one question as an activity. You can do this example and check yourself. So you can solve this question by stating their domain. State the inverse means state the domain. So you can practice with these questions. Any doubt, any difficulty, you can write under the comment space. Thank you for watching.